All right. So, yep, here is it. So it will be a volumetric analysis, but it will involve the oxidation and a reduction reaction. And in short, oxidation reduction is called a redox reaction. This today, I will talk about reduction, oxidation, reductant, oxidant, reduced, oxidized. So this mainly these three terms. And oftentimes you may find it very confusing. I warn you at the beginning that if you just have a slight, very superficial this knowledge or listening, it will be very, very confusing. But if you take some time and try to study this thing, or go through it sincerely, then it will be okay. All right. So for us, our oxidation reduction reaction, and with this oxidation reduction reaction, we can also do the titration or try to find out the amount of acid or base involved in the reaction system. Okay, so our learning outcomes for this is oxidation number. Because of the oxidation number, okay, we have to assign the oxidation number first to know whether there is an oxidation is happening or a reduction is happening. Okay, and then balance the half reaction or half equation, okay, by half. We will balance the half reaction of the first and then other half, and at the end we will equate both sides to make the full reaction. And stoichiometric calculations, we will do it based on these volumetric redox reactions. Now, first of the thing that, like anybody else, you would also ask that what is a oxidation and a reduction reaction? To sound it better, it is called a redox, but actually sometimes we say oxidation. The red is coming from reduction, or ox is coming from oxidation, but let's talk about this oxidation first. Oxidation, the mnemonic for this oxidation reduction is oil rig. Okay, oil rig. I believe that you know what is an oil rig. Inside the sea, when they the petroleum, those are called the oil rigs. But for that is the total different thing. But this term OIL and RIG, coincidentally, it is here, but it is serving as a very good mnemonic purpose, so that we can remember what is an oxidation and what is a reduction. Oil rig, oxidation is losing of electrons, and reduction is gaining of the electrons. So since to gain electron, I need to have some available electron, only then I can gain the electron. That means logically, there should be some electrons to be gained, and that it's called oxidation is coming. Okay, so in all any reaction that is happening, all right, any reaction, there is an electron involved in it. Electron are being involved in that any kind of chemical reaction. It is transferring. Okay, the electron transfer is the main thing that is happening, and that is why we are having the new product. We are mixing A and B, we are getting C and D. So this some kind of electron transfer has been associated with all the chemical equation. Only the thing is, the oxidation state for some reaction, for some compound or the reactant to compound, the oxidation state does not change. And that is why those reactions are not called oxidation reduction reaction. But for other reactions that happens to be difference in the oxidation reduction, they are called the redox reaction, or they fall below the redox reaction. So since oxidation is a losing of electron, and we know that electron, the charge of an electron is a negative. I mean, electron carries negative charge, right? And proton carries positive charge. We have seen it before. So when electron is being lost from some of the element or atoms, let's say for an atom, some electrons are lost, that means the positive charge is increasing. All right, so positive charge is increasing, and that is why oxidation is happening. And reduction is the opposite thing. That means we are taking the electron to become reduced. Okay, I mean that compound, chemical compound, is taking the electron or accepting the electron to become reduced, and that is what is a reduction is. So to go before, go deep into the oxidation reduction, we need to first know what is the how the oxidation reduction, or what is the state of oxidation reduction is happening. There are few rules to associate oxidation number for species, chemical species. Those are for free elements that we see on the periodic table, right? All those elements are at their oxidation number is 0, that means neutral state. They do not have any oxidation state, it's 0. Okay, so for free element that does not carry a charge, we consider that is a 0 charge. Okay, ionic compounds, all those compounds that are elements that are carrying the charge, those are, or ions are ionic compound. The oxidation state of the whole compound, or the is equal to the charge that it is carrying. For sodium chloride, for this case, let me take so sodium and chloride, if it is broken down, sodium and chloride will be produced, right? And then sodium will always carry one positive charge. Chloride will carry negative charge. So sodium and chloride, when they are together, this positive and negative, equal amount of positive and negative, they are getting fixed, neutralizing each other, and that is how they are at the 0 or norm, without charge state, neutral state, sorry, yeah. Okay, and same goes for aluminum oxide and calcium fluoride. So calcium fluoride, fluorine is a -1 charge, and calcium is +2 positive charge. So when calcium fluoride, to neutralize this 2 charge of the calcium, there should be 2 fluorine. Each will be carrying 1 negative charge, and that is why there are 2 fluorine. So 2 fluoride ion, each is carrying 1 negative charge. So this 1 negative charge is being neutralized by this 2 positive charge. And at the end, they become neutral. All right. So oxygen, when there is oxygen in the compound, right? Oxygen is always considered to be -2. Okay, oxygen is always considered -2. There are some exception, and the exception is when it is with more electronegative element, that is fluorine. Which one? How do you know the electronegative element? Towards the right on in the periodic table towards the right to oxygen is more electronegative. And if we see the periodic table, we see the fluorine is just sitting on the right of oxygen. So fluorine is more electronegative. That means if oxygen is attached to a fluorine, oxygen will be positive charged and fluorine will be negatively charged. Okay, but that is an exception case. And another is superoxide that we will not talk here. Superoxide oxygen get half charge, negative half charge only. So this is it. And but in general, oxygen will be negative 2 charge. Is there a problem with the network? Oxygen will be negatively 2 charge. And for this case, if we see that H2 and oxygen, that means hydrogen is, there are 2 hydrogen atoms and each is carrying 1 positive charge, because we have seen it before, hydrogen will carry 1 positive charge. So this one is 1 times 2, because there are 2 atoms, right, with hydrogen. So there are positive 2 charge, and it is neutralized by this negative 2 charge from the oxygen that is coming from the oxygen, this negative 2 charge. Oh, sorry, yeah, okay, so each of them are carrying 2 positive charge, oxygen, and then it becomes at the end it becomes neutral, right? At the end it becomes neutral. So this is how the charges are in this. Okay, so for this case, carbon dioxide, we see that there are 2 oxygen for this oxygen atoms, 2 oxygen atoms, so each will carry 2 negative charge, so that carbon will end up to be 4 negative charge, positive 4, sorry, carbon will have positive 4, and then each of the 2 oxygen will have 2 negative each, that means negative 4, and that's how they become neutral, so that the positive 4, negative 4 cancel each out, and then it becomes neutral. Okay, hydrogen, we already have told that when there is a hydrogen in the system, it's always positive charge, 1 positive charge, but there are some exception when hydrogen is attached to the group 1 element, okay, group 1 element, that is sodium, potassium, lithium, all those, if the hydrogen is attached to that, in that case, hydrogen will be negative charge. That is an exception, just like the oxygen that we are talking about. And you know, chemistry is all about exception, mostly. Okay, and then otherwise, everywhere hydrogen will be positive charge, 1, only 1 positive charge it will be carrying. So in this case, hydrogen is carrying 1 positive charge, chlorine is having 1 negative charge, so that they becomes neutral. Okay, and molecules and ions, when just now ionic compounds, when I was talking about the ionic compounds, I was talking that okay, so I was talking about this for these ionic compounds, that for ionic compounds and non-ionic compounds, when there is a it is in the neutral state, that will be 0 charge. That means it has been neutralized, that charge. But if a compound is carrying any charge, okay, the total oxidation state of the whole compound, how many, doesn't matter how many atoms are involved in that compound, the total charge of the whole compound is equal to that charge that it is carrying. So here it is manganese and oxygen, manganese tetroxide, and the whole compound is carrying this negative charge. This negative charge is not only associated with the oxygen, or it is not associated with this manganese. Okay, it is not, but the whole compound is carrying this charge. The whole compound is carrying this charge. Okay. So how do we know in this case what is the charge for manganese, right? So manganese is let's write again for the compound, the structure of the compound, and is the -1 charge. So what will happen is we do not know what is the charge for manganese. We can denote it as X, right? And we know that oxygen mostly it is -2 unless it is with fluorine. So since it is not with fluorine, it is manganese, so we can conveniently consider it is 2 charge, -2 charge oxygen. And since there are 4 of them, oxygen atoms, so multiplied by 4, and this the sum of this X plus this -2 times 4 is equal to this, the whole charge of the compound. There was only one charge of the compound, that is one negative charge, so it is -1. The whole thing, the sum of the whole charge is equal to the -1. And if we equate this, we try to solve this, we will find that X is equal to +7. Okay, X is equal to +7, and this is the charge for manganese, that is the oxidation state of manganese. Okay, so this is what I was talking about, and there are some examples that is given, and this is I hope that you have tried or at least seen, and this is the same thing that we tried to fix it. Okay, and let's say that nitric oxide, we want to know what is the charge of nitrogen or oxidation. Sorry, I'm always in charge. This is what is the oxidation state of this nitrogen. So same way we go that we assign it X, hydrogen will be +1, oxygen will be -2, and it will be multiplied with the number of atoms that are with them. And at the end, we find that X is to positive, and carbon here we notice that HNO3 in this case it was not carrying any charge. It is a neutral, right? So that is why the total charge equal to 0. For carbonate, however, the total charge is equal to -2. This is the total charge is equal to -2 here. So from there we find that carbon is +4. The same thing will go on for oxygen difluoride. Oxygen difluoride is quite poisonous, and it is very unstable also at room temperature. And it is from there we can see that oxygen in this case is having +2 charge. Okay, our oxidation is +2, and fluorine has -2. Okay. So for the groups, group-wise, if we go through the group-wise in the periodic table, if you see the periodic table and go through the group-wise, what will happen is we will see that group 1 is always a +1 charge, group 2 is +2 charge, group 13 is -3 to +5, and that is the transition metal that we said last time. I will learn more about it, of course, that they have the variation of charges. They and the transition metals, both of them has variation of charge state, oxidation state. Okay, so here we see that due to this charge, difference or oxidation state. Oh my God. Oxidation state. Okay, due to this variation of the oxidation state, the color of the compound changes. Okay, you can see from this table that for titanium, when it is positive 2 oxidation state, it does not show any color, but when it positive 3 state, it shows a purple color. For chromium is very colorful, that is at positive 2 oxidation state, it is blue, positive 3 it is green, and positive 6 it is orange color for this chromium. So this is quite interesting and this thought-provoking that why with the oxidation state they changes their color. It's all about the external electron and then how the electron behave with external what is called it influence. All right, external influence, how do they behave in this situation with the different oxygen electron number, they will behave differently, and that is why the color of the things changes. For vanadium, even for vanadium itself, it has many oxidation state, I mean various oxidation state. So from 2 till 5, we see the color changes, and it is characteristic color. So some of the vanadium in their oxidation state, it is very much toxic. So from there, we can understand that the vanadium, it is present in the solution or in, let's say, in the food or water, whether it is that toxic or not that toxic. Oxidation number and nomenclature. So the compound's name, it depends on the oxidation number as well. Iron, since they have iron and all this transition metal, right? They have various oxidation state. So they form different compounds with various oxidation state. Iron, when forming with the 2 oxidation state, okay. Okay, so this is, it will be 2 oxidation plus 2, and this chlorine will be -1 because chloride has a -1 charge, right? And since there are 2 chloride, so there will be 2, it is neutralized by these 2, and that is how this compound is not carrying any charge, because the oxidation state, the total charge has been neutralized. So that is why iron is called iron 2 chloride. However, iron 3 chloride is also possible, and it is called iron 3 chloride or ferric chloride. But this is the new rule for nomenclature to show the oxidation state. It is easier and better to, I mean, if I say ferrous and ferric and blah blah thing, you have to remember. But if we just say iron 2 or iron 3, then I don't need to remember. I just understand that what is the oxidation state of the central atom. Okay, for mercury, however, you see that there are 2 mercury and 2 iodine, right? So if I just divide by 2, both sides, I will have 1:1. So that means 1 mercury is attached to 1 iodine, and then that is why it is mercury 1 iodide. But in this case, it is mercury 2 iodide. Okay. Same goes for lead and lead oxide. I mean, lead oxide as well. All the fireworks that we watch and we enjoy are due to this oxidation reduction reaction that happens into that the chemicals that are used for these firecrackers. There is a much interesting thing, a reaction happens, and this is due to the, I mean, we feel pleasure or we enjoy it just because of their changes in oxidation state. So magnesium that form 2 oxidation state, 2 positive 2 oxidation state, that is will show one color. When this magnesium is in being reduced, they will show another oxygen. I mean, another color. So when we see in the sky at night that the color of the firecrackers changes from bright orange and then to very red and to greenish. So all about the changes of the different type of metal ions with different oxidation state. That is not only magnesium, chromium can be used, and other metal ions can also be used due to this. So when magnesium is used and magnesium loses 2 electron, right? Magnesium loses 2 electron, and that is how it becomes positive. Since electron is negatively charged, so when this electron is lost from this atom, it of course becomes positive. The charge balance is imbalance, or when magnesium was there neutral, I took out 2 electron that is negatively charged, so that positive charge increases by the same magnitude, and that is how magnesium becomes 2 positive, and it is oxidation reaction is happening, because oxidation is losing of electron, and here magnesium is losing the electron. It will only lose the electron when there is someone to take up that electron or receive that electron, accept the electron. So for this case, there is oxygen, and oxygen is taking the electron that is being lost or released by this magnesium. So oxygen is taking the exact amount of the electrons, and it becomes reduced. Okay, it is getting reduced by taking that amount of oxygen, electrons that was used there, and the total reaction goes like 2 magnesium and 1 oxygen atom is producing magnesium oxide, where it is oxidized and here it is reduced. Okay, so this is one example. This oxidation and a reduction reaction happens or occurs together. If there is oxidation reaction, there must be a reduction reaction as well. All right, so oxidation and reduction reaction. So we already have seen that what is oxidation and what is a reduction. Now, oxidant and reductant. We will be talking about oxidant and reductant. So oxidant, that is the compound or the species that is undergoing reduction or causing oxidation to others. Okay, so this is how it is. Although it is an oxidant, but it itself feels the reduction. All right, so here for this case, magnesium, the oxidation is happening for this case, but this is a reductant. Okay, because it is reducing this oxygen. All right, so this is a reductant. Although oxidation is happening here, this is a reductant, and vice versa. This is a reduction is happening here for this oxygen, but it is a oxidant because it is causing the oxidation to the other half or other species, that is magnesium. So this is one thing to take care of because it is confusing, I understand, and you have to understand so that it will be easier. All right. So identifying oxidant and reductant. That is magnesium. For this case, we see that magnesium and oxygen here. Magnesium is becoming positively two charge, and oxygen is forming two negative charge, where oxidation is happening to the magnesium, but it is actually a reductant. That means it is reducing other, and although oxidation is happening here, but it is reduction is happening here, but it is actually oxidizing other, so that it is an oxidant. That is the agent that cause oxidation, or a reductant is the agent that cause reduction. So this is in that way we can define. Now the balancing half equation. Because oxidation reduction reactions, sometimes it looks or it feels that it is very daunting, you know. It is feels very big, and it's problematic to solve. So what we do is we can do half reaction or half equation part by part, so that our problem becomes smaller first, and it is easily manageable. All big problems, you can break it down to small problem, and then you can manage it better. So balancing, that is the same thing that we'll do for this oxidation reduction, that balance the equation in smaller part, break it down to smaller parts, that is half. So the first one is magnesium and oxygen, magnesium happening. So there are some rules for balancing the equation, that we all balance all the species or element except hydrogen and oxygen. At first, at the beginning, we don't consider hydrogen and oxygen, but other things. Hydrogen and oxygen we will take care later on. So the other elements we will balance first. When hydrogen is coming, oxygen, later on we will balance that oxygen by making it or by forming it as water. Okay, not just oxygen itself, but we will make this oxygen as water, so that the oxygen is balanced. And hydrogen will be balanced in acidic condition, because acidic condition means there are more hydrogen or proton, because we already have seen that acid means which can give proton or hydrogen ion. So in that case, we will know that when it is an acidic condition like this, it says that acidic condition, that means we already know there are much more hydrogen atom or protons are there. And with the rest of the charge that will be there, we will be balancing it using the electrons, or adding or subtracting electron, either side where it is suitable. So that this will be the rules for balancing the half equation. So for this case, we see that magnesium, that is reducing, where is it? Okay, that is magnesium, that is happening, producing magnesium 2+ charge, or from here it was 0 at this position, it becomes +2 charge. So to become +2 charge, it has to lose electron, right? Electron is negatively charged, so it lost electron, and that is how it only became +2 charge. All right, so that magnesium becomes 2 electron negatively charged. Magnesium become oxidized. All right, oxidation is reduction, losing the electron. So magnesium is oxidized. And then the other half of the reaction, what is happening is that oxygen is taking up that electron. right? Oxygen is taking up that electron and it becomes reduced. But for this case, we see that here there are two atoms. There are two atoms of oxygen, and here there is only one atom of oxygen. Since it is a balancing of the reaction and it is charged, it is two negative charge, right? So there is something we are missing here. That is what happened to the another oxygen atom, right? And how come it becomes two negative charge? So what is happening? Because it was zero, how this coming from? Where does it get the electron? And how many electrons does it need? So from this oxygen O2, it is producing O2 negative, right? O2 negative. Just focus on this O2 negative, don't focus on the 2 plus. Okay, so we had two atoms here, we had two atoms of oxygen here, and we have only one oxygen atom. So if we multiply by this 2, okay, if we multiply by this 2, then I am having two oxygen already. So in this case, I am at least better in position that I started with two atoms of oxygen. Here I also have two atoms, but the charge is not yet taken care of. So there are two charge each of the oxygen atoms are carrying, and there are two oxygen atoms. So that means there should be 4 electron, 2 times 4, right? So there should be 4 electrons. So oxygen here, this oxygen should be reacting or taking up 4 electrons in order to produce this O plus, 2O negative. So it is taking up 4 oxygen, and then we see that the electron is balanced on the both sides. Okay, but the thing is, this 4 electron, where does it come from, right? We have 2 electron, the other half of the reaction, the magnesium, we have 2 electrons here. So if I multiply this magnesium with 2, so that I will get 4 electron on this side. If I have 2 atoms of magnesium on this here, so that I will have 4 electrons here. And that is happening here, so that 2 magnesium, right? 2 magnesium and oxygen is reacting to produce magnesium oxide. Okay. What is the reaction? Here. So 2 magnesium and oxygen and producing 2 magnesium oxide. So this is the reaction. In this way, it is balanced. Okay. Now go to the another one. Question number solution 2B. That is nitrate ion. Nitrate ion, somehow it is producing dinitrogen oxide. Let me check. Okay, so here nitrate ion NO3, 1 negative charge, is producing dinitrogen oxide, that is a laughing gas, that is called the laughing gas. So this dinitrogen oxide is produced. What are we missing here? We at the beginning we see that there was one charge of these ionic compounds. Then since it is carrying a charge, so it is ionic, and then there is no charge, it is not carrying any charge, so it is a neutral state. And from here we see that there is only one nitrogen, but for this case I see it is 2 nitrogen atoms. All right, here I see 3 oxygen atom, here I see 1 oxygen atom. All right, so what is happening? That means where does this 2 oxygen atom go, and where the another nitrogen is coming to this, and what happened to this charge also. So if we do this half reaction, we try to solve the half reaction. That is, nitrate ion is producing. So this, after there is one oxygen, so there should be two more oxygen left, or we should have another two oxygen, right, per one mole of this. Now, from this balancing of the reaction, we can just, first of all, we can just multiply with these two so that at least the nitrogen is solved. And otherwise, we cannot have the nitrogen. There is no other thing is coming, right? We are not adding up any other nitrogen compound. So what we have to do is multiply with the stoichiometric ratio so that we can find out this nitrogen, like N2. Okay, so since there are two already here, that means there will be 6, now 3 oxygen atom and multiplied by 2, so it will be 6 oxygen atom, 6 oxygen atom. And here there is already one taken, so there will be left is 5 oxygen atom, not 50, it is 5 oxygen atom. All right, 5 oxygen atom. Each one oxygen atom can produce only one water, all right? Because in H2O, there is 2 hydrogen, 1 oxygen. So 5 oxygen will produce 5 water molecule. And as per the rule that we already talked about, that oxygen, we do not need to balance at the beginning, but oxygen will be balanced by forming it to water. And that is what happening here. Since I have balanced 5 oxygen here, the 5 water molecule will be produced. And then we are much better off this at this position, because I already have 5 oxygen, 6 oxygen atom already solved, 2 nitrogen atom already solved on the both side. But there is a to solve this, there is a new problem generated. That means hydrogen atom. I had to add hydrogen atom to produce water, and for this case, I had to add 10 hydrogen atoms to produce 5 oxygen water molecule, right? 10 hydrogen atom, 5 times 2 atom, 5 water molecule, but in one water molecule there is only 1 oxygen atom, 2 hydrogen atom in one molecule. So since there are 5 oxygen water molecule, I need to produce, I have to have 10 hydrogen atoms there. So 10 hydrogen atoms, and hydrogen atom carries positive charge, so that I add, to neutralize the whole thing, I added 10 hydrogen atoms or hydrogen ions. When I added 10 hydrogen ions, I see it is getting much better. It is much closer to each other. So the hydrogen is balanced, oxygen or atoms are balanced, nitrogen atoms are balanced. Only the thing that is not balanced yet are the total number of electrons, right? Total number of electrons. So for this case, there are one electron was on charge, right, on top of the nitrate ion, the one. So 2 of the molecule, ions will have, each of them is carrying 1. So that means 2 electrons are involved. So 1 each, that means here are 2. So 2 into 1 is 2 electrons are involved. 10, each of the hydrogen is carrying 1 charge. So 10 hydrogen will have 10 electrons, 8 electrons here. So now we see that 8 electrons are in deficit, right? Because here there is no charge. Here there is no charge. It is 0. It is 0. It is also 0. Water is at the basic ground state is 0. dinitrogen oxide or nothing, dinitrogen oxide, monoxide, it is also zero. It is not carrying any charge. So on that side, I have 8 electron deficiency because I am adding 10 hydrogen, that means extra electron. So I have to provide 8 electrons, and these electrons are added up. All right, so these electrons are added up, and this is the balanced equation. You may ask that where these 8 electrons are coming from. That one we are not showing it here because it is, since it is nitrate, right, carrying a negative charge, maybe there are something else involved in the reaction, but we are only considering the half reaction here. Okay, only that. We are not balancing out the whole equation. Okay. Another one, this dichromate or Cr2O7 carrying 2 negative charge, it is producing chromium 3 ion or chromium 3 chromic ion. Okay, so the reaction, the first thing that we have to balance is, here there are 2 we started with, here only 1, right? So what we'll do is just multiply by these 2, and there is nothing else. So I just need to balance this and this, that is involving whatever the electron or hydrogen or oxygen. I will just balance this one out. Okay, so this chromium, since there are 2 atoms of chromium on the left side and 1 chromium atom on the right side, I have to balance this out, and I just multiply by this 2, and it is producing 2 chromium ion. That means the first step is solved, that I balanced out the elements except hydrogen and oxygen. So first, after that, to balance this out, I already produced, I mean, if you break it down, I mean, when it is broken down, the oxygen is there, right? Where it will go, it will be here. So I have to show it because I started with it. So these oxygen are produced, and I see that there are 7 oxygen atoms are here. Where is it? Okay, the cursor is, okay, so I have 7 oxygen atoms are here, and 7 oxygen atom can produce 7 water molecule only, right? Because each water molecule, there will be 1 oxygen atom. So 7 water molecule will be here. So I added 7 hydrogen, 7 H2O, so that my oxygen is also taken care of. My oxygen is balanced. 7 I have 7 here on the right side. 2 chromium I also have 2 chromium. Okay. So as I started, I produced 7 water. In this case, I also needed hydrogen, right? So 14 hydrogen I had needed for this case. So 14 hydrogen, I have to add this 14 hydrogen to make it balanced on the both side. I added 14 hydrogen on the left side so that hydrogen is also taken care of, the number or hydrogen atom, hydrogen ion. Okay, and now only the thing that we are having the difference is the electron number. Here on the left side, I have 2 negative, and each hydrogen is having 1, so 14. But on this side, I am having, here it is 0, no charge, but here I have 3, and the each of them 3, so it will be 6 electron. So how many electrons I am still, deficient from the right side? So there is 6 electron I have to add so that the electrons on the left and right will be balanced in this case. So I just added 6 electron on the left side so that no, not this one. I don't know. Okay, so no. So on the both side, number of electrons are also balanced in this case. Can anybody tell me what is happening here? For chromium, is it happening oxidation or reduction? It's not said, right? Anybody can answer? Is chromium having oxidation or reduction? Oxidation. Reduction. Yeah, this is the binary option, so you can only say oxidation or reduction. First, let's Gabriel, you are very clever, huh? Reduction, but I said whether oxidation or reduction. Okay, so let's say that how do I erase? Oh, there is eraser. Okay, so try to find out the oxidation state. Chromium to O7 to negative charge, right? So I do not know how much is the chromium one. So X times 2, because 2 of them, plus 7 oxygen atom. Each of them are carrying 2 atoms, so that it will be, and the total charge it is carrying also negative 2. In this case, if we solve this X, right, if we solve this X, it is going to be 6. It's going to be 6. And we had started with 6. From there, it was chromium was positive 6 in this case, and it is becoming positive 3. So in this case, it is reducing, gaining electron or losing electron. It is gaining electron, right? If it gains electron, only then the negative charge of the electron will come in, and then it will neutralize this positive charge. So 3 electron, it will take 3 electron. If it takes 3 electron, then out of this 6, 3 will be gone. So 3 will be gone. This 3 and 3 is cancelled out. The rest 3 is here. So since it is taking the electron, right, is gaining the electron, so it is a reduction. So chromium is going under reduction, but it is an oxidizing agent or is an oxidant. All right. Let me check the question. Any question you have? Oh, quite many questions. So what did the 5 water molecules come from? Bernice, I think I explained about it, because to balance out this oxygen, this is the rule, okay? To balance out this oxygen, you make the oxygen atom to water. You cannot just leave oxygen like O2. You cannot. This oxygen atom should be on the right side, should be shown as a water. So that is why the water is coming. Megan, is it okay to combine step 2 and step 3? better show it in a clearly step by step. I know sometimes it is easy, but when it is complicated, all right, if you combine all these steps together and write in one equation, maybe those who are examining, if not me, if it goes to the third examiner, second examiner, they will not understand, and then they'll say it's wrong. Or maybe they'll see that you have not shown the steps, so that that will be maybe a problem. So better show the step by step. Gabriel, sir, for the product part, we must write the real formula or cation, right? Not cation, right? We must write. No, you have to show, I mean, for the half reaction, you show the ions, cation, anion, whatever, you show the ions for the half reaction. But when it is the full reaction, we are going there, then you have to show this, the no charge total. Okay, no more question. Now we are going to this question who asked just now? Gabriel. Okay. Overall ionic reactions. Okay, ionic equation, overall ionic equation. When we write the overall ionic equation, when a pale green solution of iron, okay, iron Fe2, iron is also different. If in Fe, when it is oxidation state 2, it is a bit brownish, or how to say that, greenish brownish, but when it's 3, it is reddish. So this is also because of the oxidation state. Okay, when it is in pale green, right? So that when it is in pale green and it is mixed with manganese tetroxide, right? Manganese tetroxide, and manganese. Hold on, is there a problem? So when the manganese is tetraoxide, there is a problem that I suspected. The front is broken. It will be here. Okay. Oh my God. It will be total wrong thing if we do this. Yep. Manganese tetroxide. Okay. Oh. So it says that when a pale green solution, right, is mixed with a purple color solution of manganese tetroxide ion, the purple color disappears because manganese will go some oxidation reduction. Iron will also go some oxidation reduction. They will show different color. So if we write a balanced overall ionic equation for this reaction using half equation method in the acidic condition, this is to be something, don't, I mean, take it lightly. It is a big, it is giving us some big clue. Acidic condition. Acidic condition means a lot of hydrogen ion, okay? A lot of hydrogen ion. So, okay, so the overall reaction, right, it is like, it goes like that, that iron 2 is producing iron 3, manganese tetroxide is producing manganese 2 ion. So both are in aqueous medium. Both are in aqueous medium, okay? And we will show the ionic reaction only when there is an aqueous medium. If it is a solid, there will be no ions produced. It has to be dissolved in aqueous, only then we can be You can call it aqueous medium. Okay, so write a balanced overall ionic equation for this reaction using half equation method. All right, so this already happened, and then the balance equation, half balance equation, that is iron, we have already seen that it is from this reaction Fe2 plus is producing Fe3 plus, right? Fe2 plus is producing Fe3 plus, and in this case we just need to understand that the difference in charge. We have a positive 2 charge here, we have positive 3 charge here. So what happened actually? The iron actually took one, lost one more electron. So when one more electron is lost, that means here we had 2, on that side we had 3, so that we have another one that has been lost by this iron or has been produced after being iron 3 produced. So if we take this -1 to this side, right, if we change the side, it will be converted to +1, negative sign will convert to positive, and that is how it is both sides. Now it is same. So this side also 3, this side 3. So in both sides this is equal now. So what I mean, +1 means it is producing 1 electron, or it is releasing 1 electron. When it is releasing 1 electron, that means oxidation is happening to this iron. Okay, oxidation is happening to it. In this case, manganese tetroxide, for here, we see that, I mean, we don't need to go through step. We can directly add the hydrogen because this oxygen has to be balanced. This manganese is produced, MnO, Mn plus. Here, what is the oxidation state of manganese here? What is the oxidation state of manganese here? Quickly can you tell? So manganese will have +7 oxidation state in this case, but in this case it is only 2, right? If we try to find out the oxidation state of manganese from this ionic compound, I will find the manganese is having +7, but in this case it is +2. I mean, it is taking up electron. 5 electron is taking up, only then it is producing +2 electrons. That means it is being reduced. All right, it is being, the manganese is being reduced from this case. Since there are 4 oxygen atom is here, so that we can only produce 4 water molecule from this side. And to produce 4 water, I have to add 8 hydrogen. So this 4 times 2 is equal to 8, and that is what is making this. I mean, I'm with good balance now because I have 8 hydrogen. I have 8 hydrogen here. I have 1 manganese. I have 1 manganese here. I have 4 oxygen atom. I have 4 oxygen atom here as well. But the problem is only the balance of the charge, right? Because this hydrogen, this manganese was taken for 5 electrons, and then I added this 5 electron on this side. So this 5 electron is taken up by this manganese, and it produces from my +7 to +2, right? If it takes the positive, I mean electron, the positive number will reduce. So that is why it's called reduction. So 7. So in this case, I see that in this case, I see that the electron is also balanced. Or if I see, I mean, if I want to balance the electron, we take this 5 on this side, right? 1 in this side. So it will be positive 5, positive 1, and then it is positive 2 is already there. So is 8 on this side and 8 on the reactant side. So in both cases, 8 and I mean the electron, the number of electron is equal. But now the question is, from where do I have 5 electrons? If I do not, I mean, if the reductant, or if in the oxidation state, I am not having 5 electrons, I cannot expect my reduction to happen, take up 5 electrons. Where do I get the electrons from, right? So this electron should come from this part. It must come from this part. And one iron is producing only 1 electron. If I have 5 iron, okay, then I should have 5 electron easily. I should have 5 electrons easily, and that is how I can produce 5 electrons. That is how I can produce 5 electrons. Okay, so yeah, so in this way I will see that the my equation will be balanced by if I multiply by 5, and then only I add these 2 step up, this one and this one. I add these 2 step because iron is one reactant, manganese tetroxide is another reactant, so that I add this up, and I see that after I add these 2, I will have this overall ionic equation, this one. I will have overall ionic equation this, because these electrons, 5 electrons, for this case probably it will be yeah, here this is the reactant side, this is the product side, this is reactant side, this is product side. So 5 electrons I have in reactant side, 5 electrons I have on the product side. So if I take this 5 on the other side, I have to change the sign of it. It will be negative, and if it is negative, then they will cancel each other. This is the thing is happening, that I am cancelling these 2 electrons from the each side, and I do not need to show this electron at the for the overall reactions. Okay, so this is the thing. This is the overall equations. So for this case, we see that we have already covered these acid-base reactions and then the redox reaction. And we say that from this redox reaction, actually, we can produce, or we can estimate this titration reaction, or estimate how much acid or base is there. Okay. How much acid is there? Okay, hold on. I produced a Mentimeter, but did not save it. My bad. Okay, so for the redox titration, we can use, or we can analyze different product and find out the amount of that product, or the total amount of the ions, of course based on the ions, based on the titration, a redox reaction. Based on the redox reaction, we can find out the amount that is present in the compound. And this is the thing that you are going to do for your experiment 3, right? And this is kind of a redox reaction. You have to show the redox, you will see the redox reaction, I will upload it. And you have to you will find it the half reaction, and it will be easier for you when you do the half reaction of these things. For this case, another one, it says that potassium permanganate, right, reacts with hydrogen peroxide. Potassium permanganate reacts with hydrogen peroxide to produce manganese and iron and oxygen, right? Which of the which one is the oxidant and the reductant in the reaction? So the answers are given here as well already, but both of the thing, actually, magnesium tetroxide and hydrogen peroxide, is oxidizing agent. All right. So which one is stronger oxidizing agent? Can anybody tell? Which one is strong oxidizing agent? Hello? Anybody there? Mn. MnO4, I think we say. MnO4. Okay. Yes, because this one is oxidizing, right? This is oxidizing the other. That means it is a strong oxidizing agent. And actually the solution is here. Thank you. From here we see that the oxidation state of manganese, which was 7, positive 7, of course, it becomes positive 2, right? From positive 7, it becomes positive 2, and that means it becomes reduced. It took the electron and it gained the electron, so it becomes reduced, and since it is it itself become reduced, so it is a oxidant, is oxidizing other. Hydrogen peroxide, however, is from -1, because this is one exception. Hydrogen, both of them are 1. Hydrogen is hydrogen is +1, oxygen is -1 for hydrogen peroxide, H2O2. However, hydrogen is +1 still, but oxygen is -2 in water. Okay, so this is one thing to note. And when it is from the hydrogen peroxide, it is producing oxygen. It is going to being reduced, right? From -1, it becomes to 0. It becomes to 0. How does it become 0? Because it is lost electron, right? So it lost electron, and it goes undergoes oxidation, so that it is a reductant. For hydrogen peroxide, again, it is producing water, and the hydrogen in both cases, hydrogen in both the hydrogen ion and hydrogen here, it is not changing any of its oxidation state. That means it does not involved in this oxidation reduction. So that means it is just watching, it is not taking part in the reaction by contributing the electron or taking the electron. So there is the question was asked that 25 milliliter of 0.02 molar potassium permanganate solution is reduced by 20 milliliter of hydrogen peroxide solution. What is the concentration of hydrogen peroxide solution? It goes as like the M1, V1, M2, V2, only the thing that we consider the number of the moles, okay? number of electrons that will be involved in this, and the volume of the solution. Okay, so here it says that 0.02 moles of potassium permanganate, 0.02. Sorry, what I'm saying is okay. So for this case, we see that manganese tetroxide, that is oxidant, that's oxidizing, but it's getting reduced, and hydrogen peroxide, which is a reductant, which is getting oxidized. So this is producing manganese and water and oxygen. So 0.02 molar of manganese tetroxide, we use 25 milliliter of this in this concentration. 20 milliliter of this hydrogen peroxide also used, but what will be the concentration of that to get the whole thing neutralized? That means none of them are oxidized, I mean oxidant and reductant at the end. So how much, what is the concentration that should we be using? Okay, so it goes as N1, C1, V1, in this case C2, V2. Only the thing is we should divide by the number of stoichiometric ratio for this oxidation reduction reaction. Only this is the exception thing or extra thing that you should remember, that number of stoichiometric ratio. Okay, stoichiometric ratio we should be divide it with by, and from there we find this concentration of hydrogen peroxide. Another example for wine, since wine has ethanol, and sometimes it can it can produce acetic acid sometimes, and it is bad, so that we need it's time to time we check the concentration of the ethanol or acetic acid that has been produced to maintain the quality of it, and it is checked by acidified potassium dichromate solution. The ethanol, how is the concentration or percentage of ethanol in the solution? It will be, it says that 10 milliliter of the wine or the alcoholic beverage was taken and then it was diluted, and 10-fold dilution was happened, and this titration was done with acidified potassium dichromate solution, and the titer was taken, it was needed 24 milliliter. Okay, it was taken 24.61 milliliter of the titer. So the same thing, we know the concentration of the dichromate solution, but we do not know the concentration of the ethanol, but we know the volume of the ethanol that was taken. At the end, the reaction is from the oxidation state of chromium. Here is a 6, and it becomes to +3. So here the reduction happened, right? Here the reduction happened because the chromium took 3 electrons by itself. 3 electron by itself, so that the chromium becomes 3 positive rather than 6 positive. Prolot, sir, after the dilution, the number of moles is still the same, right? Yes, the number of moles are same, only the concentration will be changed. Okay, if I take 10 milliliter of the solution, and let's say X number of moles in the 10 milliliter, if I make to 100 milliliter, still there are X number of moles of that. Okay, so what is happening? What is that? Oh, okay, chromium is going through this reduction because it is taking up the electrons, and it goes in the same way, that is N1, C1, V1, C2, V2, and from there we can find the concentration of ethanol in the wine or in the alcoholic beverage. So since we find the number of moles, from there we can find the concentration and multiply with this dilution factor, right? Okay, 530, that's why. Dilution factor, so that we find the concentration of this ethanol in the solution, the original concentration of the undiluted solution. After that, he says that percent volume over volume, right? Volume percentage, volume by volume percentage rather. It will be, we have to show the volume percentage, so that how can we find the volume percentage is milliliter by 100 milliliter, okay? In 100 milliliter, how many milliliter of ethanol will be there? Since we already know there was 1.85 molar or concentration of this, and from there we find this 1.85 mole of ethanol is in 1 liter, because 1.85 molarity of the solution, right? So that in 1 liter, how many moles of this ethanol will be there? So it is multiplied by 46 gram per mole. From there we find 85 gram of ethanol, and the density of the ethanol is 0.789 milligram per liter. So we just divided by this. From there we find in 100 gram of ethanol is actually 107.8 gram of it. So it is in 1000 milliliter, or after all 100 milliliter, how many percentage? So we find that it is 10.78 volume by volume percentage. One thing is when you are calculating your lab results, I see that you did do it in different way, or a different logic you are using. You are very welcome to use different logic. I like that actually. But please, when you are going to a different logic or different ways to solve the problem, at least explain that what process, because sometimes I don't know 0.3, 0.8, where it is coming from. It's very tedious to go back and forth, where did you find that one? So if you tell that, okay, 0.3, the number of moles, or from where it comes from, 0.8, where it comes from, that is much easier. Now, another, just now we are telling, just now we talk about the alcohol, and nowadays it becomes a very big problem for this drink driving. A lot of accidents are happening with this, and of course it's bad for our health as well. So police checks in Malaysia, of course, time to time they sit on the road with this alcohol breathing test to check whether somebody is drinking or driving, like that way. So what happens here? There is no chemical test is done on the lab, but there is a electrode method, electrochemical process. It's called electrochemical process when in that process. So there is electrode, that is anode and cathode, right? And in anode, here, this alcohol is converted to this acetic acid, and at cathode, it is the oxygen for breath analyzer actually. This oxygen is reduced to negative 2 charge, okay? It's reduced to negative 2 charge, it's not 0. It reduced to negative 2 charge, but here it was 0 charge. So it gain the electron and it becomes reduced in cathode. The opposite thing happens for this. Here alcohol become oxidized and produces carbonic acid, or there one more oxygen here, and produces the. So this is how this the machine says depends on this concentration of how much the oxygen is being taken out from this air, or how much electricity is being produced, because the electrons, they are being produced, right? How much electricity is being produced, because of based on that, the instrument gives the result, whether it is below the level or above the level. Okay, so here for the summary, the oxidation reduction, it is oil rig. Oxidation is losing of electron, and a reduction is taking the electron or accepting the electron. And when there is an oxidation is happening, that is actually a reductant. And when the reduction is happening, on what the reduction is happening, that is the oxidant actually. Okay, and volumetric analysis can be also this mind this what do you call it formula. It will be needed for us time to time, and it is useful for sometimes. Okay, so that is it for today. And do you have any question so far? Is there any question anyone has?
Sir,
Mm-hmm.
for page 19.
Page 19, hold on, I go there. Okay. Yeah.
Lower one more page. 2 page. Yeah,
Yeah.
this one. Teacher, I'm still confused why the Cr2 is not undergo oxidation reaction.
Cr2 is undergoing oxidation reduction. What? What is
it?
it?
But just now you mentioned is undergo reduction reaction.
Yeah.
But I found out is oxidation reduction reaction.
Okay. I mean, your question is why chromium is going to this reduction reaction, is it? Or, I mean, can you once again, please?
I calculated by myself. I found out this equation is undergo oxidation reaction, but just now you mentioned is reduction reaction.
No, I'm saying that chromium, right? Chromium, what is the oxidation state of chromium here? For this case, I mean, can you see my cursor? Okay.
Yeah, it's equal 0, right? For Cr2 because it's atom.
Okay. Okay, here, this chromium, right? Here, what is the oxidation state here? It is positive 6, isn't it? Positive 6. Isn't it? Can you, I'm writing, oh, I don't know, the network is bad. Okay, yeah, now say that I'm writing here, this is positive 6. Okay. Here, the chromium is positive 6 on this, yeah. Oh, it's, I'm actually writing on the, but I don't know, is network problem or why it is not showing? Okay, let me try here again. It is not showing. Okay. Why you don't see it full screen, right? Yes, the network is very bad. Hello,
I can
hello,
hear
can
you,
you
sir.
hear?
I can hear you. I can hear you.
But I'm actually on full screen and I'm trying to show, but I don't know why it is not going to the full screen. Okay, I write it here. Okay, on the left, just below the solution 2 CR207, the chromium has positive 6 charge, isn't it? Okay, Gabriel?
Okay.
Yeah, the chromium has positive 6 charge, but on the right side, on the product side, it has positive 3 charge. That means it lost 3 positive charge. How did it lose positive charge? That means it took up 3 electron, because each electron will carry only 1 negative charge. So since it took 3 electrons, and that is why it is going through reduction. Chromium is being reduced. Okay. Is that your question? Hello. Oh my God. That's what I was saying, that why the chromium is being reduced, because it was taking up electrons, 3 extra electrons. Hello, guys. Can you hear me?
Yes, sir. I can hear you.
Okay. So, what was it your question? So, is it clear now, or do you want me to go over? I'm okay. We will still have 20 minutes to go, so should be okay. Okay. So, all right. Now, okay. So, another, is there any? Yes. Yes. Thank you for typing that. And then on the right side is the reduction is happening. Okay, so any other question? Anyone has any other question? Any other question? Okay. All right, so then I will go through the roll calling quickly, right? So please respond by voice, not just type, because I see and then this takes time. Muhammad Anis bin Abu Hassan al-Sahri. No, absent. Xiang Wei, Tio.
Here.
Thank you. Carlord just typed, so I think he is here. Nishimitra. Nishimitra absent. Okay, Rezvi.
Yes, sir, present.
Thank you. Hao Liang Sun.
Yes, teacher.
Thank you. Gwenda was here.
Here.
Thank you. Temi,
Here.
Yu Chen Chong.
Here.
Thank you. Kelvin, I think Kelvin
Hello.
was, yeah.
Here.
Intimisha Ntambu.
Here.
Okay. Yemen,
Here.
thank you. Sophia,
Here.
Marjan,
Present, sir.
thank you. Veran,
I'm here.
okay. Gia Kiki,
Yes, sir.
Bernice was here, I saw. Chen Liang Teo,
Here.
thank you. Megan,
Here.
Jia Wei Sun,
Here.
Angel,
Here.
Darren Kwang,
Here.
Jun Hyang Chia,
Here.
Brandon Sim,
Here.
Adelaide,
Here.
Sagar Shankar Roy,
Here. Here.
thank you. Lian Sunti.
Here.
Lian Sunti, you haven't submitted the lab safety form, huh?
Tonight I will send to you.
No, not to me. You upload it to the system.
Sorry, teacher.
No. It's okay, but if you do not submit it by today, you will not get marks for the lab, okay? Be careful. It is very important. Lab, as this safety form is very important. Another one did not submit, so I will check. Okay. Lian Sunti, okay. Brian Kong,
Yes, sir.
thank you. Darren John. Darren. Excellent. Siu Xian Liu. Okay. Yeah, so the other one is Intimacy and Tambu. Okay. And Jason Ting.
Yeah.
Thank you. Lik Seng Tan.
Here.
Thank you. Jonathan, already typed. Gabriel, I know. Tanya Radzwa, Sharon. Tanya Radzwa.
Yes.
Okay.
I'm here.
Okay, thank you. Chuin Chet Sim.
Here.
Thank you. Che Wen Kong.
Here.
Then Brandon William.
I am here.
Thank you. Chun Hui Chen.
Yes, sir.
Okay, so thank you very much for attending, your attention, and I'll see you tomorrow. It is, although it is not much, okay, it is not, because we are doing the same thing for titration. It will be similar thing. So it will be lab group based. So let me know if somebody is not responsive, or if your partner is not helping you. Those who are not cooperative, there will be there are consequences. Okay, there are consequences, and they will have to submit all alone. They will have to work. All right. So be careful, and not only alone, you will also we'll also keep an eye on you. Okay, so the thing is, how Liamson, teacher, may I ask about the project Scratchbook? I still not sure what to do with the Scratchbook. London. Jane, have you replied the Canvas thing? Our okay. So thing how the book that I was telling is just like frequently sorry, I think yeah, the university, I don't know, because it's 6 maybe, or why the network gets slow, not slow, weak. Can you hear now? Can't hear you anything. Okay. So the thing is, the what I was saying, scrapbook. Okay. So scrapbook is you put the date. I don't know how frequently you guys meet together. You can meet once a week, twice a week, right? Like that, or maybe more time you meet. So whenever you meet, you put the date that 22, 22nd, 23rd of September you met together, what time, and then what did you talk about, what is the not blah blah thing like have you text me or did you do that, not like that, but what is the outcome. I mean, you 4 or 5 you sit together, there are some decision that okay, we'll be doing this, we'll search this part, why it is not happening this way, how to do this part. I mean, for the next meeting when we'll sit together, what we will think about for the next meeting, the agenda for the next meeting, those all things should be sequentially on the scrapbook. It is a diary, you can say it is a diary of what you do when you do it, right? So that is it, all right? Yeah, it is kind of a record of the meeting. Yes, so minutes of the meeting, a record of the meeting kind of thing. Or it is a planner that this meeting we did this, what we are gonna do for the next meeting, like that. All right. Okay. So I'll see you, sir. Will you meet each group to see? Yes, you're very smart, huh? Yes, I will meet you guys timely basis, and I will divide the group. When do you want to meet? You can meet anytime. You don't have to wait for me. If you have something urgent to talk, you can meet me anytime. You can just no, before midterm. Before midterm, because after midterm, only after 1 week after the midterm you have to submit. Okay, if you have anything, you can contact me to ask anything. If you want to ask anything, you can contact me. But if you, I will distribute the. I mean, every 4 groups, I will in one day or one sitting, I will ask 4 groups to sit and talk with me together. Later, I will tell you when I will assign the date, like group 1, 2, 3, 4 in one day, group 3, 5, 6, 7, 8 another day, like that. Okay. For the answer of the question, we type in the PowerPoint slide or Word docs also can. For the answer of the question, put in the PowerPoint slides. For the answer, what does it mean? What question? What PowerPoint you are talking about, Gabriel? The question I created. You need to. You are talking about the project, or you are talking about the lecture? I don't know what question you are. If you have any question, I mean, based on your project, you can just write, or you can just type about PowerPoint, or you just give some point basis and then you explain it, okay? It will be better to have the script because sometimes it is hard to understand. I mean, the network is not good, you know, sometimes the recording is maybe not good, so I don't understand really what you say. So one page of transcript is good, but it will. I'll instruct it later. By the way, you all morning it will be on 23rd October, as I mentioned in the Okay, so thank you very much. Have a nice rest of the day and see you tomorrow morning. Take care.